Hello guys, welcome again to my second physics class about kinematics for 10th grade. This is a new method for us, so we are learning, okay? Now this topic is about displacement with constant acceleration. You can find it in page 49. Now I'm gonna read the problem. A racing car reaches a speed of 42 meters per second. It then begins a uniform negative acceleration. Using its parachute and braking system, it comes to rest 5.5 seconds later. Find the distance that the car travels during braking. Now, for this problem, we're going to make use of the equation that we have over here. Displacement with constant acceleration is delta x equals 1/2 or 0.5. I prefer using 0.5, okay? Multiply times the addition of the two velocities, initial and final, times or multiply by the time. I'm gonna leave it over here. So, according to this equation or to this formula, what do we need for the givens? Or how can we identify the givens? First of all, we need velocities, time, or displacement. Depends on the question. Now, let's read the problem again. A racing car reaches a speed of 42 meters per second. It then begins a uniform negative acceleration using its parachute. Now, a racing car, let's imagine a racing car to be like this, okay? So it is traveling at 42 meters per second. Now it says, using its parachute and braking system, it comes to rest. Its parachute is like this. So the air that comes inside the parachute is going to slow down the car. So at the end, how is going to be our final velocity of the car? It says comes to rest 5.5 seconds later. That means that right from the moment the car starts to apply the brakes, it starts to slow down from 42 meters per second to rest or 0 meters per second. The car did it in how much time? They did it after 5.5 seconds passed. Now, what is the problem asking us to find? It says find the distance that the car travels. Now, when we talk about distance, remember we're talking also about displacement. Displacement involves direction and distance is not. But they are measured in the same units. So displacement is delta x, or the distance is unknown. This is what we're going to find. Now, what is the problem giving us? It's giving us 42 meters per second. This is the initial speed of 42 meters per second. After a time of 5.5 seconds, the car comes to rest, or that means that it's not moving anymore because of the parachute and the braking system. So that means that the final velocity is 0 meters per second. Now, do we have everything that we need to calculate the distance? Yes, we have velocities and we have time. So we apply the formula. I'm going to apply the formula over here. Okay, you already know the problem, you already probably wrote it. So it says delta x equals 0.5 velocity 1 plus velocity final times the time. So we need to look for displacement, so we say delta x equals 0.5. Initial velocity is 42 meters per second. plus final velocity is 0 meters per second, and the time that it takes is 5.5 seconds. So this is the same as having 0.5 times 42 meters per second times 5.5 seconds. This is equal to, we use our calculator, 0.5, open parenthesis, 42, close parenthesis, open, 5.5. So that means that delta x equals, or displacement equals, 115.5 meters. As it is our final answer, we box it. Okay, now for the last problem, the topic is velocity and displacement with constant acceleration. I'm gonna read the problem as usual. A plane starting at rest at one end of a runway undergoes a uniform acceleration of 4.8 meters per second square for 15 seconds before takeoff. What is its speed at takeoff? How long was the runway be for the plane to be able to take off? Okay, now if you read the title and you look in page 51 or page 50, you're going to find out that these are the equations that we're going to need for this problem. Velocity and displacement with constant acceleration, and this word is the most important for this problem. Constant is the same as saying uniform. Okay? Constant and uniform are the same. Now, what do we need? First of all, we need to understand the problem. We're talking about a plane. And I'm not very good at drawing, but I'm going to draw a plane over here. Ooh, look at this. Amazing plane. Okay. Let's say that's a plane. So, okay, well, the plane was at rest. So initially, in one side of the runway, because we have runways, okay, in the airport. So initially, the plane was at rest, and after acceleration, what happens is that the plane increases its velocity in a way that now it is able to take off. Okay, sorry about the noise. Okay, so when it reaches a certain speed, after having this acceleration, now the plane is able to take off. Now, initially, how was the plane? It says starting at rest. That means that its initial velocity is equal to 0 meters per second. Okay, you're not able to see it, but it's right here. 0 meters per second. Now, the final velocity, it's unknown because it says what is its speed at takeoff. In this moment, right here, the plane starts to take off. So we need to know the velocity in this point. Now, what is the second question? How long must the runway be? How long must the runway be? Now we're talking about the size of the runway. Okay, its length. How long should the runway be for the plane to be able to take off? Now, we're going to start writing the givens. The first given is starting at rest, so we say that the initial velocity is 0 meters per second. Uniform acceleration is important. Uniform acceleration is important, and it's 4.8 meters per second square. And now for 15 seconds we're talking about time. Now the problem is asking us to find the velocity at takeoff, which is the final. We already said y, final velocity, unknown. And also the runway should be how long. How long must the runway be? Okay, so we're talking about its length, or how long we're talking about displacement. Delta x is also unknown. So here, to solve this problem, we're going to do 2 steps. Okay, first one equation and then the other. 1 and 2. Now, let's see if we have everything to find the final velocity. We have initial velocity? Yes, it's 0. Do we have acceleration? Yes. Do we have time? Yes. So we can start by finding the final velocity. So we say final velocity equals initial velocity plus acceleration times or multiplied by the time. The initial velocity, we said that is 0 because it says starts from rest. 0 meters per second plus acceleration, which is 4.8 meters per second squared, and the time, which is 15 seconds. This is 0, and this is, you will use your calculator here, so it will be 0 plus 4.8 times 15. This is 72 meters per second. As it is a final answer, we're going to box the answer. Now, in all these problems, if you can see, we haven't done any conversion because it's not necessary. Velocity is given in meters per second, so perfect. Acceleration is given in meters per second squared, so perfect. And the time is given in seconds. But for example, if I give you time in minutes, you have to do the conversion from minutes to seconds. Now that we have the final velocity, we're going to try to find out what the displacement is. So it says delta x is equal to initial velocity delta t plus 0.5 acceleration time to the second power. We know that the initial velocity is 0, so all this term will be 0. Why? Because 0 times 15 is going to be 0 plus 0.5 acceleration, which is 4.8 meters per second squared, and the time, that is 15 seconds to the second power. So how do we solve this in the calculator? We write 0.5 times 4.8. Now take a look at this. This square is inside the parentheses, so that means that you don't need to raise it to the second power. But the time, yes. Look at the equation. Here the time is raised to the second power, and here 2. But acceleration is not raised to the second power, so here you don't have to raise it to the second power. Okay, so 4.8 is not raised to the second power, but it's multiplied times 15, which is raised to the second power. Take a look. Equal. This is 540 meters. So in conclusion, this problem tells you that for the plane to be able to take off, it needs a final velocity of 72 meters per second. And to reach this velocity, the runway should be at least 540 meters. If this runway is less than 540 meters, the plane won't be able to take off. And probably an accident will happen. That's why physics is very important, guys. So try to analyze these problems very carefully, and I'll give you the homework in the PowerPoint presentation. So see ya. Enjoy.